Let's take a look at hydrogen bonding. Hydrogen bonding occurs between an electron deficient or protonic hydrogen. In order to get an electron deficient or protonic hydrogen, it has to be bonded to nitrogen, oxygen, or fluorine, the three most electronegative atoms in the entire periodic table. Because by chemically bonding with these three highly electronegative atoms, it actually bankrupt hydrogen of its own electron. Meaning to say its own electrons is actually dragged primarily into the electron space of NOF. So the hydrogen atom has become delta plus, and the lone pair electron of NOF is now able to form a hydrogen bonding with the H. So the highly electronegative nitrogen, the highly electronegative NOF atoms would have bankrupt hydrogen of its own electron. So primarily, hydrogen has an empty 1s orbital, and this is when the lone pair electron of NOF could actually be bonded to the electron deficient or protonic hydrogen, giving rise to what we call as hydrogen bonding. So with that, let's take a look at some molecules. And the first one we have is NOF. NOF actually are three highly electronegative atoms, but this molecule does not have an electron deficient hydrogen. So therefore, this molecule cannot display intermolecular hydrogen bonding. The next that we take a look at is actually our CH3CHO. You will find that oxygen has got two lone pair, and oxygen is a highly electronegative atom. However, none of the hydrogen is bonded to O. Therefore, none of this hydrogen is electron deficient or protonic. Again, this molecule cannot form intermolecular H-bond. In the case of water molecule, there are two hydrogens here that we circled, which are protonic and electron deficient because they're directly bonded to oxygen. So this is a molecule that could form intermolecular H-bond. The other one we look at hydrazine. Similarly, in the same vein, we have four hydrogen atoms directly bonded to nitrogen atoms, which is highly electronegative. So therefore, this molecule can also form intermolecular H-bond. Let's take a look at the three covalent molecules that can form intermolecular hydrogen bonding: HF, H2O, and NH3. In terms of the strength of intermolecular hydrogen bonding, HF would have formed the strongest intermolecular hydrogen bonding because fluorine is the most electronegative. And you'll be followed by your water, since oxygen is the next most electronegative. Then finally, your ammonia, all right, as nitrogen is the least electronegative. However, in terms of boiling point, it is interesting to note that water, in fact, has the highest boiling point. The reason for that is because per water molecule has two lone pair electrons as shown here, and it has two electron deficient hydrogen as circled. So on average, it can form twice the number of intermolecular H-bond or more extensive intermolecular H-bond relative to actually HF. Because if you take a look at HF, although fluorine has three lone pair electrons, HF only has one electron deficient hydrogen. So on average, they could only form one intermolecular H-bond. Finally, let's compare these two molecules. You'll find that this molecule has lower boiling point than this, since it formed intramolecular H-bond. What is intramolecular H-bond? Intramolecular H-bonds is when two groups of atoms which are close to each other could form hydrogen bonding. So in the case of this molecule, this hydrogen which forms intramolecular H-bond is no longer available for intermolecular H-bond. Therefore, because of this molecule will now form less extensive intermolecular hydrogen bond relative to this molecule, and hence this molecule will end up having a higher boiling point.